Hello student, let us see the next part of the objective 1. We have seen question number 1 to question number 5 in last class. The answer of, let us go ahead with 16 questions are there in objective 1. So let us see the sixth question. The sixth question is, what is sixth question? That there is a turnable table and at any point when the particle is observed, it is rotating. The speed of the particle is 20 centimeter per second and the angle acceleration of the particle is 20 centimeter per second square. Now this particle is shifted to at a distance r by 2 from the center. We have to find out the new value of the speed and acceleration. Now we know the v old is, let us take old velocity, speed is 20, acceleration old is this much. Now nu can be written as omega times r by 2. Now I can say omega times r by old is omega r and that is 20. So I can say omega r is nothing but it is 20. Now I can find out the new speed as omega r by 2 and that is nothing but 20 by 2. So I can write down it is 10 centimeter per second. Now how to find out the new acceleration? Now new acceleration is nothing but v new acceleration divided by r by I can say this is v new square by r new, and v new is 10 and r new is r by 2 so 2, and what we'll see the value of r is 20. If I say how to find out, I can say acceleration old is v square by r. So from there r can be obtained as 20 by 20 into 20 by 20. So this is 20 centimeter. So I can place the value of r as 20 here. So you will observe new acceleration is 10 centimeter square, 10 centimeter per second square is the new acceleration. Is it clear? So which is correct answer? The correct answer is A 10 centimeter per second is speed and 10 centimeter per second square is acceleration. This is the correct answer. Now seventh question is, water in a bucket is rilled in a vertical circle with a string attached to it. The water does not fall down even when the bucket is inverted at the top of its path. We conclude in this position. Now if water is not falling, for question number 7, if you take at top of the circular path, let us take, this is the bucket, right? This is the bucket and this is rotating with v speed. Now if water is not falling, we will observe the normal reaction on the water, weight of the water. This provides the centripetal force. So n plus mg can be written as mv square by r, or I can say the normal reaction is nothing but mv square by r minus mg. Now you will observe water will not fall only when normal reaction is greater than 0, or I can say mv square by r is greater than mg. Is it? Now what is the answers? Answers are mg is equal to mv square. The answer A is wrong. Option A is not correct. Second, mg is greater. That is also wrong. Third, mg is not greater than mv square. Now third one is correct. The correct answer for the seventh is answer is C. The weight of the mg or the weight mg is not greater than, it is less than mv square by r, so not greater than. Now let us say question number 8. What 8 says, a stone of M is tied to a string of length L is rotated in a circle with other end string at the center. The speed of the stone is v if the string breaks. Now once the suppose this particle is moving with v speed. Now it is rotating, right? Now once this speed break, then the particle moves in the direction of tangent, because everywhere in the circular path the speed, the velocity of the object is towards the tangent, in the tangential direction. So whenever the string breaks, it continues moving with its initial velocity in the direction of initial velocity. So it always moves in along the tangent. The correct answer for the 8 is C. It moves along a tangent once the string is broken. Now question number 9. A coin is placed on a rotating turntable, just slips if it is placed at a distance of 4 cm from the center. If the angular velocity of it is doubled, it will just slip at. Now once it is at 4 cm, it is rotating. The frictional force for question number 9. Let us see for question number 9. Question number 9. Now once it is at 4 cm, now at 4 cm, you will observe the frictional force will be acting here, and frictional force can be written as m omega square r. R is nothing but 4. Is it? Now when you what if angular velocity is double, it will just, if it is doubled, now if it is doubled means the new frictional force, the new centripetal force will be equal to m times 4 omega square, and let us take the new radius is r. Now this is the maximum value of frictional force, so these two can be equated. I can say it is m omega square 4, so you will get this cancel, or I can say r is 1 centimeter. So you will observe when the angular velocity of the turntable table is increased, when it is placed at 1 centimeter, then only it will just slip at a distance of 1 centimeter. But once the angular velocity was omega, it was slipping at 4 centimeter. If omega is double, at 4. If it is triple, then less than 1 centimeter. Is it? Now question number 10. A motorcycle is going on an overbridge of radius r. The driver maintains a constant as the motorcycle is ascending on the overbridge. The normal force on it. Very interesting question. That is, you see a car is moving on a vertical circular road. Let us, if the car is moving towards the suppose a vertical circular road, bridges is there. So at the top we will observe the normal reaction and weight is acting, but before reaching at top, the component of weight comes into picture. So let us see that part, how to find out in those situations, how you can find out these things, the normal reaction, how it is happening, whether it is increasing or decreasing while it is reaching at the top. Now the basic concept is you will take the component, of the weight in the direction of center whenever it is moving on circular path. So that part we'll see how to find out the normal reaction, whether it increases or decreases. Now let us see that part. So let us take if you just, it's for question number 10, I am explaining here. Question number 10, I am explaining how to find out. Now if you take a circular path is like this, so let us say circular path is like this, and as the object goes towards the top, this is top center, and let us say this is center of the circle. Now here you will observe the normal reaction, N is in this direction and mg is acting in this direction. Now when you join it, this angle is theta, so you will observe this angle is also theta. So you will get the component of mg towards the center is mg cos theta. I can say here mg cos theta is providing it is acting towards the center. So I can say mg cos theta minus n is equal to mv square by r, or I can say n is nothing but mg cos theta minus mv square by r. Now what you will observe, as the object goes towards, theta is decreasing, and theta decreases means this value is increasing because cos 0 is 1. Now once it is increasing, n will be increasing. So as theta is decreasing, n is increasing. So what is correct answer? As the vehicle goes to the top, the normal reaction increases. So for 10th, question number 10, The correct answer is A, it increases. And increases while the four-wheeler goes to top of the circular road. Now, after this you can say, once it reaches at top, when it goes in this direction, once again the normal reaction decreases there. While it is reaching to top, normal reaction increases. The moment it goes down, the normal reaction is decreasing. So that part is also clear. Now 11th question is three identical cars A, B, C are moving at the same three pitches. Car A on plane, B on convex upward. Now very interesting question. Question number 11. Question number 11 is, this is a level road. Let us take A is level road. B is convex upward. This is B. And C is goes concave upward. This is C, right? There are three types of bridges. Now you will observe, if the force, suppose four-wheeler is here, the vehicle is moving here, the vehicle is here at the top, you can say, and the vehicle is here. Now, right, see. Now here you will observe the normal reaction if the force exerted by the ground is Fa in upward direction, this is mg. Now here you also observe Fa balances mg. If it is moving with V, so there is no centripetal force towards the center. Now here you will observe mg is acting in downward direction and Fv is acting up. So you can say the net force acting towards the center is mg minus Fb is mv square by r. So I can say Fb nothing but mg minus mv square by r. Now in this case you will observe the normal reaction or Fc is acting toward the center, mg is acting down. So I can say Fc is minus mg is mv square by r, or I can say Fc is mg plus mv square by r. Now what you observe here, we observe Fc is maximum, right? And then it is greater than Fa, and then Fa is greater than Fb. So this is the thing, how the force is exerted by the ground on the vehicle. Now answer C is correct because Fc is maximum of three forces. Fc is maximum. So for this correct answer is C, right? Fc is maximum. Fc is maximum. Is it clear? This part is clear. Now let us take 12th question is also very interesting. A train A runs from east to west. Now two trains are there for question number 12. Let us take, this is the diagram. These are the two diagrams, equator. And in one case, train moves east to west. Let us take, this is east, this is west. So a train is moving from east to west, or I can say, let us V is the speed for A. This is train A, right? Train A is moving. Is it clear? East to west. Another train B of the same mass runs from west to east. Now let us take, this is east, west to east. Another train is moving west to east, that is V. Now we know at the same speed along the equator, A presses the track with the force F1 and B presses with the track F2. We have to find out which is greater, F1 is greater or F2. Now once on the equator, you will observe the force acting towards center. Here you will observe mg is acting towards the center. This is direction of mg towards the center at the equator, and F1 is acting in this direction. Is it clear? Here also the mg is towards the center, and then Fb, F2 is acting on this. And since here you will observe that mg minus F1 is m. Now let us see, from east to west it is going, train, and earth rotates from west to east, so there is difference. So I can say V minus omega r, m V square by r. And for this case, west to east, So Earth is also moving, rotating from west to east. So I can say in this situation, mg minus f2 is m v plus omega r square by right. Now f1 will be this minus this part is less, so less is deducted. So f1 is more, and here more is deducted, so f2 is less. So what we observe, the correct option is f1 is greater than f2. Is it clear? Since here why we are subtracting, why we are adding in case of 2, because Earth also rotates from rotate from west to east, and the train is also going from west to east. So both the velocity is added. Now in the first case, one train is from east to west, Earth is from west to east, so the speed of the train is deducted here. So less amount is deducted, so f1 is more and f2 is less. Now let us take the next question, question number 13. If Earth stops rotating. Now in case of Earth, let us see what happens. Now, whenever Earth is, when we find out Earth is rotating from west to east, and if any point is selected on the Earth's surface, its acceleration is given as g minus omega square r cos square lambda. Now, let us see the effective acceleration. I can say for question number 13. For question number 13, the apparent acceleration or G effective can be written as G minus the angular speed of the Earth is omega square r cos square lambda, where lambda is latitude. Now at equator what we observe that lambda is 0 degree. So G at equator can be written as G minus omega square r, and G at pole, lambda is 90 degree at pole, so cos 90 is 0, so G pole is 0. Now what is question? If Earth stops rotating, now means omega is 0. Now once it is 0, the G at equator will increase, but G at pole will remain same. So what is correct answer? For the 13th question, the correct answer is increases at some places, means at equator it will increase and remains constant, and remains the constant at other places, means at pole it remains G. If Earth stops rotating, then on equator at different places the value of G will increase. Now question number 14 is we have to find out a rod of length L is pivoted at one end of the rotated. Before, let us see 15. Question number 15. Once the simple pendulum having bomb is suspended from the ceiling of a car used in stunt films, the car moves along an inclined cliff at speed v and makes a jump from the cliff. And once the car is free fall, then you will observe the tension is 0. The bomb falls with mg, and there is no centripetal force at all. So once the car is freely falling, the tension will be 0. Now for question number 15, the correct answer is D, that is 0. And question number 16 is let theta denote the angular displacement of the same oscillating in a vertical plane if mass of the bob is m, the tension is mg cos theta only at extreme position. Why? Because at extreme position V is 0, so the tension will